Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In the previous class we are learning about hybridization and types of hybridization. You know there are three types of hybridization: SP hybridization, SP2 hybridization and SP3 hybridization. Already we have studied about SP hybridization and along with examples. Now in this class we are going to study the second type of hybridization, that is SP2 hybridization. SP2 hybridization. You know the meaning of hybridization. Hybridization is nothing but a phenomenon in which the overlapping of S and P orbitals, or the overlapping of equal energy or almost similar energy orbitals to form a set of equal energy orbitals, that we call hybridization. Okay, here to define SP2 hybridization, one S orbit and two P orbitals is overlapped together and to form a equal energy set of three SP2 hybrid orbitals. That phenomenon we called as SP2 hybridization. Okay, so in SP2 hybridization, one S orbit and two P orbits. See, one S and two P, that is one S orbit and two P orbits overlap together, and you get three set of SP2 hybrid orbitals. This is called what? Hybrid orbitals. These hybrid orbitals having same energy, that you know in the features of are characteristic features of hybrid orbitals. There we learn these hybrid orbitals having same amount of energy. This is the first point. Now these SP2 hybrid orbitals are oriented in three different directions in the form of equilateral triangle. And before going to that, in SP2 hybridization, there is one S orbit and two P orbit. Totally there are three orbitals. And you know the percentage is calculated by 100. How many orbitals are there? 3 orbits. 1s and 2p. So after dividing you get 33.3%, right? So 1s orbit, it means the s character is 33.3% and 2p orbits are there. So that the p character is how much? 66.6, that is equal to 7. So the P character is how much? 66.7%. This is the S and P character in SP2 hybridization. Then here observe the S orbit is spherical in shape, that you know. Spherical in shape. Then P orbit is dumbbell in shape. P orbit is dumbbell. How many P orbits are there? 2 P orbits. This is one dumbbell shape and the second dumbbell one is this one. This is one S orbit. This is 2 P orbits. Now these two overlap together, you get three set of SP2 hybrid orbitals, right? Those three sets are this one. One is S orbit, one hybrid orbital, then second hybrid orbitals, and the third hybrid orbital. This is the third hybrid orbitals. Here you get a set of three SP2 hybrid orbitals. This one, hybrid orbitals. So after overlapping these two, you get this one that we call SP2 hybrid orbitals. These are called negative lobes and these are the positive lobes. This is the hybrid orbitals that are having equal amount of energy. Now observe the fourth one, means fourth point in SP2 hybridization. These three SP2 hybrid orbitals are oriented in three different directions to form an equilateral triangle. See, observe, this is an equilateral triangle, right? Like it looks like a triangle. So the bond angle between two lobes from this one to this one, this is 120 degree. So the lobes are separated by 180 degree. Hence the geometry of this molecule or shape of the molecule is trigonal and planar. This looks like a plane and looking like a trigonal, so that the geometry or shape is shape or geometry both. He is a trigonal planar. Trigonal planar. So that is written as TP, trigonal planar. Simply represented by TP, trigonal planar, or just write trigonal planar. So this is the detail of SP2 hybridization. Now to learn in detail about SP2 hybridization and some examples, take the best example is boron trichloride. Take example 1, boron trichloride, BCl3. Boron trichloride. So observe in SP2 hybridization, the central atom or ion having SP2 hybridization. Okay. Now here we are taking boron trichloride. Boron is the central atom and 3 chlorines are there. Now take the boron. Boron, its atomic number is how much? 5. Hydrogen H, helium H, lithium Li, beryllium Be, and boron B. That is 5. Atomic number is 5 that you know. So write electronic configuration 1s2, 2s2 and 2p1. This is the electronic configuration, right? The outermost is 2s2 and 2p1. Now write it in orbitals. 2s containing only one shell and 2s shell containing only one orbit and 2p containing 3 orbits. This is 2p. This is 2s2. So how many electrons are there? 2 electrons with the opposite spin. And S containing only 1 electrons. So this is the electronic configuration in what? Ground state. Okay, this is electronic configuration in ground state. Now observe how many chlorine atoms are there here? 3 chlorine atoms. But here there is only one single electrons. The single electrons or unpaired electrons only participate in hybridization. Okay, therefore to make 3 chlorine bonds with boron, or boron to make 3 chlorine bonds with 3 chlorine, one of the electrons which is present in 2s orbital is jammed to the vacant 2p orbit, because these two are present in same shell and having same energy. So iವೆರಡು ಒಂದೇ ಶೆಲ್ ಅಲ್ಲಿ ಒಂದೇ ಎನರ್ಜಿ ಇರೋದ್ರಿಂದ ಏನಾಯ್ತಂದ್ರೆ ಒಂದು ಬೋರಾನ್ 3 ಕ್ಲೋರಿನ್ ಆಟಮ್ಸ್ ಜೊತೆ ಬಾಂಡ್ ಆಗೋದಕ್ಕೆ 2s ಆಗಿರುವಂತ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ p ಆರ್ಬಿಟಲ್ ವೇಕೆಂಟ್ ಅಂದ್ರೆ ಖಾಲಿ ಇರುವಂತ p ಆರ್ಬಿಟಲ್ ಗೆ ಜಂಪ್ ಆಗುತ್ತೆ, ಎನರ್ಜಿನ ಗೇನ್ ಮಾಡ್ಕೊಂಡು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಆ ಗೇನ್ ಮಾಡ್ಕೊಂಡಿರೋ ಎನರ್ಜಿ ಮತ್ತೆ ಬಾಂಡ್ ಆದ್ಮೇಲೆ ಲಿಬರೇಟ್ ಮಾಡಿಬಿಡುತ್ತೆ. Okay, so that will happen in excited state. So in excited state, ES, the electronic configuration is, this is the 2s, one of the electron is jumps from 2s to 2p, that is written here, 2s to 2p. Now 2s there is only one electron, and in 2p there are 3 orbits, one is here and the second electron jumped to one. So it is jumping of electrons takes place. Now observe, 1s and 2p orbits is there. 1s and 2p orbits. Totally how many electrons are there? 3 single electrons. Here also 3 electrons are there. Out of 3, one is paired, means 2 electrons are paired and one is vacant, single. Here all these 3 are singly occupied. So that they involve in hybridization. Now 1s and 2p orbits, these two becomes 3sp2 hybrid orbitals. Okay, 1s orbit, 1 to 2p orbits, totally 3, and 1s and p, that is sp2 hybrid orbital. 3 sp2 hybrid orbitals you get. Okay, now you know how to write these 3 sp2 hybrid orbitals of boron. So this is for boron only, right? So the boron having 3 sp2 hybridization. Now you know how to write 3 sp2 hybrid orbitals. How we are writing in the last explanation of about sp2, like that. Okay, so this is one sp hybrid orbit, that is sp2 hybrid orbit. Then second one, second sp2 hybrid orbit, and the third one, like, okay, this is the what? 3 sp2 hybrid orbitals. The central metal atom is boron. So here there is boron. Boron having sp2 hybridization, right? This is the boron atom I am writing. Now 3 chlorines are there. What is the atomic number of chlorine? Chlorine, the atomic number is 70. So electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. Okay, this is the electronic configuration. And you know outermost shell is 3s2 and 3p5. So in 3s electrons are completely filled, right? And in 3p 5 electrons are there, those are filled like that. Now there is one vacant electron here, right? One chlorine make a bond with boron of 1 electron. ಇಲ್ಲಿ ಒಂದು ಕ್ಲೋರಿನ್ ಅಲ್ಲಿ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಬೋರಾನ್ ಜೊತೆ ಬಾಂಡ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ಎಷ್ಟಿದೆ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, 3 ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ. ಇಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ 1 ಆರ್ಬಿಟ್, 1 ಎಲೆಕ್ಟ್ರಾನ್, ಸೆಕೆಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ and third electron. 3 electrons. Here p, this is 3p, right? 3p5, 5 electrons. This is 3s2, 2 electrons. Now you know the p is double state, that is from chlorine. 1 chlorine donates 1 electron. Like that 3 chlorines donates 3 electrons from their p orbitals. Those are overlap end to end to these 3 equal energy hybrid orbitals. You get a trigonal planar structure. Now observe this p orbit is double, right? 1. See, 1 chlorine atom is overlapping like that. It containing 1 electron, right? That is, I am writing like the opposite thing. Now similarly, one more p orbital of chlorine. Here opposite spin electron. Okay, this is what from chlorine, Cl. This is also from chlorine, Cl. Now similarly, the third one electron is written right like that, and the p orbital overlap. So this is from chlorine. So this is called what? Overlapping. Electrons overlapping. Okay. Now the boron atom having SP2 hybridization, central atom. Now observe, this is like what? Trigonal, triangle. Looks like a triangle, right? And it is in a plane. So the geometry is what? Trigonal planar. Trigonal planar geometry of structure. Okay. Now this can be simply writing like that. Boron and 1 chlorine atom like that, this one, and the second chlorine atom like that, and the third chlorine. Okay, now this is called boron trichloride, trigonal planar geometry, trigonal planar geometry. Okay, this is the hybridization, SP2 and example. Now take one more example, that is ketene. Now second example. Example 2 for SP2 hybridization only, ketene. The molecular formula is C2H4. That is called ketene. It is an alkene, first member of alkene. Okay. Now here the central metal atom is carbon. Okay. So how many carbons are there? 2 carbons. How many hydrogens are there? 4 hydrogens. For each carbon, how many hydrogen we get after dividing? 2 hydrogens. Okay, that is CH2. Then double bond, CH2. For each carbon getting 2 hydrogens. This is the structure. Now we want to know here how the structure will get for this molecular formula. C2H4 ಗೆ CH2 double bond CH2 ಅನ್ನೋ ಸ್ಟ್ರಕ್ಚರ್ ಯಾವ ತರ ಬಂತು ಅನ್ನೋದೇ ನಾವು ಇಲ್ಲಿ ಮಾಲಿಕ್ಯುಲರ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನಲ್ಲಿ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಮತ್ತೆ ಮಾಲಿಕ್ಯುಲರ್ ಸ್ಟ್ರಕ್ಚರ್ ಈ ಬಾಂಡ್ಸ್ ಯಾವ ತರ ಇದೆ ಸ್ಟ್ರಕ್ಚರ್ ಯಾವ ತರ ಬಂತು ಅನ್ನೋದೇ ದಟ್ ಇಸ್ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಅಂಡ್ ಮಾಲಿಕ್ಯುಲರ್ ಸ್ಟ್ರಕ್ಚರ್ ವಿ ಆರ್ ಲರ್ನಿಂಗ್. ಓಕೆ, ನೌ ಟೇಕ್ ದಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ atom carbon. Carbon is an heavy metal. Carbon atomic number is 6. Now electron configuration is 1s2, 2s2 and 2p2. Totally 6 electrons are there. 2 plus 4, 6. Outermost shell containing 4 electrons. Now write in electronic configuration. Orbitals. 2s shell containing 2 electrons and 2p containing 3 orbits, 2 electrons. Like that. Okay, this is electronic configuration in where? Ground state. Now observe. Totally there are 4 hydrogens. After dividing, each carbon gets 2 hydrogens. Here 2 hydrogens makes bond with 2 hydrogens make bond with these 2 electrons. Then what about the second carbon? How the carbon will be make bond with the neighboring carbon or other carbon? That will be happens only when free electrons are available. So when you get free electrons, when the carbon take energy and electrons jumps from one state to another state, then only you get free valence electrons or single electrons. Okay, at that time only the bond will be formed. Now in excited state, therefore these two s orbitals gain energy and jumps the electrons from one of the 2s to 2p orbital. 2s ಇಂದ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಎನರ್ಜಿ ಗೇನ್ ಮಾಡಿಕೊಂಡು ಬೇಕಿಂಗ್ 2p orbital jump ಆಗುತ್ತೆ because both have same energy. So in excited state what you get, s containing one electron 2s and 2p orbitals containing single electrons, one electrons. Now totally how many valence electrons are there? Sorry, how many singly occupied valence electrons are there? 4. 1, 2, 3. These are the single or unpaired valence electrons. Now here one s orbit and one two p orbits. One s orbit and two p orbits overlap together and form a set of 3 sp2 hybrid orbitals. One s and two p. This is not overlap one, means we call unhybridized p orbital. This is 3 sp2 hybrid orbitals in it. Okay, one s and two p. This is called hybrid orbitals. Hybrid orbitals. And observe, this third p orbit is not participating in hybridization, right? So that it is called unhybrid orbit. Unhybrid. Unhybrid orbital. This is hybrid orbits. Now you know this is the electronic configuration of carbon and arrangement and overlapping of orbitals. Similarly, 4 hydrogens there, one hydrogen having atomic number only 1 and the electronic configuration is 1s1. So that is written like that, 1 electron. And you know the shape of s orbit is spherical. Okay, this is spherical shape. Here observe the unhybrid p orbital shape is dumbbell. Got it? Then you know these 3 sp2 hybrid orbitals is looking like that, right? Already I told you like that. These are the 3 sp2 hybrid orbitals. sp2 hybrid orbitals. These are the negative lobes, bit small in size. Okay, this is sp2 hybrid orbitals, this is s orbit and this is p orbit of this one, unhybridized. Now all these three overlap together and you get a C2H4 molecular structure. Now observe these three sp2 hybrid orbitals, this is only for one carbon. Now observe that is written like that. This is one sp2, sp2, that is 3 sp2 hybrid orbital. This is for one carbon. How many carbons are there? 2 carbons. This is only for one carbon. Here write C. Okay, carbon. Similarly, one more set is there, right? So 3 orbits are 3 electrons. 1, 2, 3. ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಇರುತ್ತೆ. ಆ ಕಾರ್ಬನ್ ಬರೀತಾರೆ ನೋಡಿ. Here carbon, right? One hybrid orbital, second hybrid orbital, this one, then the third hybrid orbital, Now here there is one electron for this orbit. Here orbital one electron irutte, aವೆರಡು ಏನಾಯ್ತು side ಒಂದಕ್ಕೊಂದು ಸೇರ್ಕೊಂತು bond ಆಯ್ತು. Similarly here one electron and here one electron. Got it? These are the one carbon, this is one carbon, second carbon. Illond carbon, eight carbon ಆಯ್ತಲ್ವಾ, ಇದೊಂದು carbon ಅಲ್ಲಿ ಇರುವಂತದ್ದು ಇದು. 8 carbon ಗೆ ಸರಿ ಇತ್ತು. So yes, hydrogens ಇದೆ 4 hydrogens, ಒಂದು s orbital ಇದೆ, ಒಂದು hydrogen. ಈ ತರ 4 ಇದೆ. those hybrid orbitals s orbitals overlap here, one s orbit overlap aito, one electron bottom, idu s which is from hydrogen. Similarly the second hydrogen s orbit, one electron donate, this is hydrogen. Then third hydrogen donate electrons and makes bond, and similarly fourth hydrogen electron ಕೊಟ್ಟು bond ಆಯ್ತು. ಸೊ ಈ ತರ 4 ಹೈಡ್ರೋಜನ್ಸ್ 4 ಕಾರ್ನರ್ಸ್ ಅಲ್ಲಿ p ಆರ್ಬಿಟಲ್ ಗೆ ಓವರ್ಲ್ಯಾಪ್ ಆಯ್ತು. ಸೊ ಇದೇನು ಎಂಡ್ ಟು ಎಂಡ್ ಓವರ್ಲ್ಯಾಪ್ ಅಲ್ವಾ, s and p ಏನು ಕೊಡ್ತು, s and p ಓವರ್ಲ್ಯಾಪ್ ಆಯ್ತು, ಸಿಗ್ಮಾ ಬಾಂಡ್. ಅದೇ ರೀತಿ ನೋಡಿ end to end overlapping, right? These hybrid orbitals are end to overlapping, that is also sigma bond. End to end overlap ಆಯ್ತು ಏನಂತ, sigma bond. Now ಇದು ಓವರ್ಲ್ಯಾಪ್ ಆಯ್ತು, ಇವು ಓವರ್ಲ್ಯಾಪ್ ಆಗುತ್ತೆ, 4 ಹೈಡ್ರೋಜನ್ಸ್ ಇಂದ 4 hybrid orbitals 4 corners. Then from each carbon 3 SP2 hybrid orbitals, these two overlap together. Now the remaining is only unhybridized p orbit from each carbon. ಇನ್ನು ಉಳ್ಕೊಂಡಿರೋದೇನು, ಒಂದು p orbit ಇದೆ unhybridized ಪ್ರತಿಯೊಂದು ಕಾರ್ಬನ್ ಅಲ್ಲಿ. So that is dumbbell shape. Now write dumbbell shape. This is dumbbell shape. Dumbbell. So dumbbell ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಈ ತರ ಏನು ಲೋಬ್ಸ್ ಇರೋದಿಲ್ಲ, ಹೈಬ್ರಿಡ್ ಅಂದ್ರೆ ಈ ತರ ಲೋಬ್ಸ್ ಸ್ಮಾಲ್ ಲೋಬ್ಸ್ ಬಂದಿರುತ್ತೆ, ನೆಗೆಟಿವ್ ಲೋಬ್ಸ್. ಸೊ ಒಂದಾಯಿತು. ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಅರ್ಥ ಆಯ್ತಲ್ವಾ. ಸೊ ಇದೊಂದು ಕಾರ್ಬನ್ ಇಂದ p ಆರ್ಬಿಟ್, ಇದೊಂದು ಕಾರ್ಬನ್. Now these two p orbitals overlap side way overlap ಆಯ್ತು, side wise overlap ಆಗ್ತದೆ ಪಕ್ಕದಲ್ಲಿ. When sidewise overlapping of these hybrid orbitals is results pi bond, right? This is the pi bond overlapping. So both are same representation of pi. Now this is the overlapping. Observe its structure can be written. This is the molecular structure. Now this can be written like that: one carbon here, second carbon. So this is sigma bond, right? One bond and sigma, that is hydrogen. Here one bond and hydrogen. Got it? Similarly for this carbon also, second carbon also like that. Okay. Now here observe overlapping of orbitals, get sigma bond, right? Sigma bond means right one bond, that is what, sigma. This is also sigma. Okay. Now the pi bond, these two is representation of pi bond. So write one bond, that is pi. Side way overlapping like that, side by side, get pi bond. So this is the molecular structure of heating molecule and the final structures. Okay, totally how many sigma bonds are there? 1, 2, 3, 4, 5. 5 sigma bonds plus 1 pi bond. Totally 6 parts are there. Okay, so here also observe 1 bond, second 2, 3, 4, 5, and this is the 6th bond. Okay, this is the molecular structure and detail about SP2 hybridization. Next class we will learn about SP3 hybridization.